Hello, we're students from Tech de Monterrey, and we will show you a great experience and opportunity we had.
We participated in the workshop Nanomaterials and Advanced Materials at Rice and Berkeley, in which we got to visit these two prestigious universities.
This project is part of a huge event organized by our university called Semana.
We traveled to Rice University at Houston to learn about nanotechnology. Nanotechnology is the study of very small materials. Very small. When you get to this scale, materials start behaving in a different way. For example, their color may change. Nanomaterials can be synthesized by many different methods that involve the knowledge of chemistry, physics, and engineering. They can be characterized in order to know all about their size, composition, structure, and many other properties and characteristics.
Professor Ringa's research involves the synthesis of nanomaterials such as nanorods, which are small structures made of gold and silver particles with an inside hollow filled with water. Because of their properties, they could have applications in different areas. She mentioned the importance of having the right tools that suit your research. For nanomaterials, electron microscopy is of great utility.
So basically, this is a machine that has an electron beam, okay, and a gallium beam, and also a beam of platinum to make electrodes. So you can basically cut through stuff and make stuff and all sorts of things. This is the electron column where basically the electrons come from the top, hit the sample in the middle, and then go through the detectors.
Professor Tu talked about nanomachines introducing the concept of building with a down-top approach instead of the usual top-down. For example, making a table from scratch instead of needing wood from a tree. He explained about building nanocars in which the molecular structure actually resembles a car and can target a specific cell surface.
These are Feringa motors, so what happens with these kind of molecules is they only rotate in one direction when you shine light on them. And so the idea was to build these in at mid-chassis.
This could eventually be used for drug delivery or to destroy cancer cells.
But I'm in the flipping things. I tell these women that it's all about a team, Jordan and Pippen, man.
Professor Matsuda talked about his research on biomolecules extracted from plants that could be used for medicine. He explained how enzymes can make mistakes and generate a wide array of different compounds. This is important for us to understand how this happens and be able to synthesize the desirable compound for a specific application.
When I saw her walking down the street, she looked so fine. I just
Professor Marty talked about carbon nanomaterials in the exact room where fullerenes were
El carbono
discovered.
está relacionada al estudio de las propiedades químicas, físicas y optoelectrónicas de nanosistemas y nanomateriales hechos específicamente de carbono.
He explained how nanomaterials behave differently in the nanoscale. For example, gold can be read at sizes below 100 nanometers.
Later, we visited the Bioscience Research Collaborative at Rice and had a talk from Professor Hargering. His work covers different areas connected in biology, chemistry, and materials. He explained about his work understanding collagen, which is the most abundant protein in the body.
Collagen triple helix is the kind of most characteristic structure.
He also talked about his work on multi-domain peptides, which are materials that can be injected to have a regenerative response. We visited the labs at the BRC and saw the equipment they used and how are they organized in order to do some of the leading research in this area.
We elaborated the synthesis of a specific porphyrin. These structures have distinctive color that can be used for medical imaging. We performed the synthesis under reflux to maintain our amounts of solvent. We used column chromatography to purify our product. We used chloroform as a non-polar solvent that interacts with our polar product. The alumina with which our column is filled is polar, so our byproducts are retained a longer time there than our product, making it come out first. We used a rod vapor to remove the remaining solvent and obtain a purple crystalline material. It was then characterized by nuclear magnetic resonance to confirm the presence of our product and determine its purity.
We traveled to University of California, Berkeley to keep learning from different research and applications in which nanotechnology is used.
Berkeley is one of the places where BASF, a German chemistry company, is working in a partnership to collaborate between research done in universities and the industry. Berkeley is part of the California Research Alliance by BASF, in which they partner with several universities in California to bring together their knowledge and applications.
We then visited Professor Jagi's lab. He has done extensive work on metal organic frameworks, or MOFs, which are porous structures that can take in other molecules and store them. Lots of different structures of MOFs have been studied, each of them showing different properties and uses. MOFs can be used for storing gases that we do not want in the atmosphere, and could be used to make carbon dioxide renewable.
Afterwards, we had the opportunity to visit the Lawrence Berkeley National Laboratory and the Molecular Foundry, where some of the top leading research in nanoscience is made.
So after 5 days of traveling and work, we got to learn firsthand about some of the leading research being done in the many different areas that are involved in the world of nanomaterials, and got inspired to continue learning.